Hi everyone, welcome to the class. Guys, please confirm once that am I audible to or not. Everyone, please confirm that am I audible to or not. And yes, please share the topic as well that we were discussing in the last class. I guess so. We have studied the Rutherford atomic model, and we have finished that. And we were discussing about the Bose atomic model. We have done its postulates. Tamalong, are you there? Confirm once. Okay. So let's start, guys. The next topic is distribution of electrons in the orbit around the nucleus. Means that was explained by the Bohr that how the electrons would be present around the nucleus. Okay. So before understanding this, means before looking at this slide, I'll clear it to you. Okay. This is very easy actually. Distribution of electrons. Of electrons. See, first of all, you need to remember the formula 2n square. You have to copy from the slide. I'll shift to that slide. I'm just clearing your concept, okay, that how you can write the electrons. These are the total electrons in the shell. This is the formula, okay. We know that n can be have the values 1, 2, 3, 4 and so on. And these are nothing but what? Shells. K, L, M, N and so on. And remember guys, you have to write the shells with the help of capital letters only. You cannot use the small letters, okay? Because small letters are used to represent the subshells that you will study about that you will study in the higher classes, okay? Now, let's say suppose, let's talk about K. If I would like to talk about the K, see, put n equal to 1, this is what? 2n square. So in the K shell, we can have what? 2 electrons. If we talk about the L, it is what? 2 square, which is what? 8 electrons. If you say M, it means we have the 3 electrons. Do not copy this guys, just understand the concept. This one will have what? 18. And so on, you can calculate the number of electrons, okay? So this is how you can represent the number of electrons in the shell. Like the K shell will have the 2 electrons, L shell will have the 8 electrons, M will have the 18 electrons, and so on. You can calculate the for N as well. Okay. Valency is nothing but the charge, or we can say tendency to form the bonds. An element, how many bonds it can form or whatever charge is present over it is known as what? Its valency. Okay. So this is how you can this is how you can determine the number of electrons present. Now, let's say suppose we have atomic number 11 and they are saying write its electronic configuration. Atomic number is 11. So how can you write the 11? See, first shell will definitely be what? K, which can accommodate only 2 electrons. Then it will be L, which can accommodate what? 8 electrons. Now, the M, which can accommodate up to 18 electrons, but up to K and L, we have already filled up what? 10 electrons. So in the last, out of 18, I'll simply put what? 1. So this is the configuration of atomic number 11, which is 281. Okay. Now, let's say suppose we have got atomic number 17. This is your atomic number. So how will I write it? 2, 8, 7. See, sum should be what? 17 over there. Okay. Let's say suppose we have got atomic number 10. So we'll simply write what? 2 and 8. Okay. If you have atomic number 7, you will simply write what? 2 and 5. Okay. So this is how you can write the electronic configuration. Okay. I hope so it is clear to everyone. Is it clear to everyone? Please confirm once. Is it clear to everyone? Anyone is having any doubt? Okay. So now you can copy this. Please copy and then confirm. Copy and then confirm. After copying that, please confirm. Done? Okay, copy then. Copy this one as well. This is an illustration of that one. Examples. Copy this one. Done. Okay, copy this one as well. Oh, this is the question, guys. Write down the distributions for this one, and after that I'll show you the answers, and you have to check at how many corrects you have got. Okay, so let's check out. Yes, very good. Okay, so let's move on. Next question. Itanaga, are you there? Okay, good time along. Itanaga. Okay, so let's check the answer. Hi, good evening, Itanaga. Good. Okay, so this is the answer. Si plus, which is 13. See, it is saying the silicon has atomic number equals to 14, which it undergoes reaction and becomes Si plus. Si plus means loss of electron and one loss of electron over there because it is Si plus. Okay. So out of 14, only 13 electrons are left. Okay. So which of the following could be the correct representation? So it would be the B, not A. Okay. Next question. Do this one as well. Okay. What's your answer? Tamil long? Okay, so let's check out the answer. Is 1. Okay, choose the incorrect statement. They are asking for the incorrect statement. The maximum number of electrons present in L and N. Yes, absolutely, this is the wrong statement because in N, LMN, N contains the 32 electrons, not the 18 electrons. So first one is the wrong statement. Okay. Maximum number of electrons that can be accommodated in outermost orbit is 8. Absolutely correct. That follows the octet rule. Okay. So you can remember that the maximum electrons in outermost shell can have only 8. Shells are filled in stepwise manner. Yes, definitely. Means you can't fill L before K, M before K, something like that. Okay. So first of all, we have to fill the K shell, then L, then M, then N, and so on. Okay. Next question. Okay, Tanaga, please solve this question as well. Tell me your answer. Okay, so in Itanaga, there is an exam going on till 4 p.m. Therefore, unable to log in until exams over. Oh, but I guess 4 is over now. Your question is correct. Okay, it's okay, Itanaga. Cool. Systematic atomic structures of element 1, 2, 3, 4 are this. The element with the highest and the least valencies. Yeah, question is correct. Valency means electrons present in the outermost shell or electrons which can form the bonds which are actually those electrons which are present in the outermost shell. Okay. Or the electrons which are present in the outermost shell are actually responsible for the development of the charge as well. So these all are the correlated statements. Okay, so let's check out. Oh, answer is D. Very good. Okay, so that's all about for this section, means Rutherford on Bohr's atomic model over. Okay, so let's move on to the next part. Okay guys, this is the question for you, recall test. Please mark your answers quickly so that we can proceed. Mark your answers quickly. Okay. Look at these questions as well. Okay. Tamalong, have you also done that? Okay, good. Check out the answer. If anyone is having any doubt, you can please ask me. Okay. So congratulations to all those who has got all correct answers. If anyone wants to ask me anything regarding this one, please you can ask. Okay. And we can start with the next part. Valency. Okay. Number 2. Okay. Let's check out number 2. Questions say according to dash, only special orbits known as the discrete orbit of electrons are allowed inside the atom. Okay. So this one was given by Rutherford, not Rutherford, Bose. Because Rutherford could not tell that what should be the position of electrons and where should they be present. Okay. So this was actually given by the Bose. The systematic arrangement of the electron around the nucleus was given by the Bose. So this is actually the same statement that according to Bose, only certain special orbits known as the discrete orbit of electrons are allowed inside the atom. Okay. I hope so it is clear to you. If not, you can please tell me. Okay, so let's move on to the valency. Tamalong, I hope so it is clear to you. Is it clear? Okay, so valency of an element is the number of electrons. See, I have already told you about the valency. It is nothing but the electrons present in the outermost shell, which are responsible for the bond formation. Okay. Now, see, is the number of electrons that its atom should give or take to attain the stable electronic configuration. That is, atom should accommodate 8 electrons. This is known as the octet rule. Means this is the rule, octet rule, which explains that only those substances can exist which has the 8 electrons in their outermost shell after gaining or losing. Okay, and after some time this rule get failed as well. Okay, but yes, this one was applicable to many compounds. Okay, so we can say the exceptions were not answerable according to these concepts. Okay, so that is, atom should accommodate 8 electrons in the outermost shell or the valence shell, except the K, which can accommodate only the 2 electrons. Okay, that you have to remember. Only K shell can have the 2 electrons in the outermost shell, whereas all the other shells will definitely have the 8 electrons. Okay, see, the numbers 2, 8, 18, 18, 32 are the total number of electrons in that shell. Okay, and the outermost shell, or the outermost orbit of that shell will have the 8 electrons. That's what this statement means. The electrons present in the outermost orbit of an atom are known as what? Valence electrons. Okay. 3 ways to obtain the stable configuration. First is by losing the electrons, second is by gaining the electrons, and third one is by sharing the electrons. Okay. Okay, I'll write it for you. First of all, you have to copy this one, and after copying that, in the three ways, uh, you can write the loss by the losing of electron, second by the gaining of electron, and third is by sharing of electrons. Okay, I'll write it for you. Just confirm me once after copying that. Means up to first point. I'll tell you them along. How do they share? Don't worry. You have to copy everything. But in the last point, see some part is misprinted over there, that there is written that three ways to obtain the stable configuration. Okay, only one is written over there. Rest two I'll write it for you. Okay, so after copying the whole page, just confirm me once. Copy and then confirm. Copied. Okay. Copy and then confirm. Okay. A part was by losing electrons. Next part is by gaining electrons. And next is by sharing of electron. Okay. Let's take an example. Let's say suppose for the K shell, it is allowed that we can have the 2 electrons in the outermost shell. Okay. So let's take example of H2. See, this hydrogen having the 1 electron, and if it can share the 1 electron from the other hydrogen, now look at the circle. Here, the hydrogen which is I have circled has got the 2 electrons. Similarly, the same can be done by what? Second one. Now, you can check. This has the 2 electrons and this one is also has what? 2 electrons. So, it means that both have the complete octet. Means hydrogen is the only case where we need to check the 2 electrons in the outermost shell. Otherwise, always we need to check the 8 electrons. Okay. So, this is how they have got the octet completion, and this can exist like this. Okay. This is the sharing of electrons, about which you will learn in the higher classes. Okay. So, I have given you the idea that how the sharing takes place. You need to copy this one. Please copy and then confirm. Means this is already written. You have to copy rest too. Copy and then confirm. Copied. Okay. So let's move on. Valence and valence electrons. See, from Bohr-Bury sequence, we know that the maximum number of electrons which can be accommodated in outermost shell is 8. Okay, cool. Every element has an arc to have the 8 electron in its outermost shell. In achieving 8 electrons, an atom can either gain or lose electron. The number of electrons lost or gained by an element achieving the 8 electron in its outermost shell will be called its valency. Okay. Like for hydrogen, helium, lithium, beryllium, and boron, these elements need to have the 2 electrons in the valence shell. Therefore, their valency is according to the electrons lost or gained. Okay, I'll make it simple to you. Just look at the screen. Let's say suppose sodium. You can see in the sodium there is only +1 charge. If I ask you about the valency, first of all, remember in the valency we need to write the magnitude only, not the plus and minus sign. You can see Na plus means it has only 1 plus, its valency will be the 1. Okay. If you say Cl minus, in the chlorine you can check there is only negative charge, 1 negative charge, therefore its valency will be what? 1. If you say Mg2 plus, you can see there are 2 plus charge, it means its valency will be 2. If you say C4 minus, it means that carbon having the 4 electrons, so its valency will be what? 4. If you say cesium plus, this is what? 1. Okay. So valency is nothing but, means this is the situation after the achieving of the octet. Okay. So after achievement of the octet, whatever charge is over there, or we can say in the achievement of the octet, how many electrons is being participated over there by the element will be its valency. Okay. Or in the simple words, you can simply remember it is nothing but the charge for the ionic species over there. I hope so it is clear to everyone. Please confirm once. Tamelong and Itanagar, guys, please confirm. Is it clear to you? Anyone having any doubt? Okay, so now you can please copy this one. Please copy. Do not do not copy the last point. Copy only first 3 points. Do not copy last point. Means I'm reading the last point. For the elements like hydrogen, helium, lithium, beryllium, boron, these elements need to have the 2 electrons in the valence shell. Therefore, their valency is according to their their electrons lost or gained. Do not copy this point. Other than this, the first 3 points you need to copy. Please copy and then confirm. Do not copy the last point. Copy and then confirm. And yes, guys, I have a surprise for you that I'll tell you in few minutes. Copied. Okay. So there are few elements whose valence is given to you. Okay. Copy. Okay. Discussion means you have to write your views after reading this. See, atom that have 1, 2, 2 or 3 electrons in the outermost shell can easily donate them to achieve stability. Okay. Similarly, atoms that have 5, 6, 7 electrons in outermost shell can easily accept 3, 2, 1 or 1 electrons respectively to achieve the stability. However, consider carbon. It has electronic configuration 2, 4, which means that it has 4 electrons in the outermost shell. What do you think would be easier for the carbon to achieve stability, accept 4 electrons or donate 4 electrons? Or you can come up with a new way to achieving the stability for the carbon. This is the question for you guys. Need not to copy the last point. Okay, so this is the discussion question. They are saying if valence is 1, 2 or 3, means the outermost shell electrons has the 1, 2 and 3, it is easy to donate, whereas in case of 5, 6 and 7, it is easy to accept. Means for those elements which are having 5, 6 and 7 electrons, they would like to accept the electrons in spite of donating the electrons. Okay. Whereas they are saying the carbon has the 4 electrons in the outermost shell. So what should carbon do? It should donate or accept. What do you think? What do you suggest? Write your views. Then we'll discuss about it. Mean, how can you say neither? Means it should do something, na? It should accept or donate. What do you suggest? Done, Tamalong and Itanago? Are you ready? No, you need not to copy it. It is just a discussion question. No? You have to think about it. Okay, let's check out. See, donating or accepting 4 electrons requires the higher amount of energy. Hence, carbon rather choose to share its electron. Okay. For example, if carbon have to form a bond, both of them would share their 4 electrons with each other. The shared electrons are now part of both the carbon atoms, hence the both of the atom will achieve the stability. Such bonds are formed by the sharing of electrons called the covalent bonds, about which you have to learn in the higher classes. If I would like to summarize it, I'll say simply that it is always convenient for an element that is having the 1, 2 or 3 electrons to donate. Okay, means they would like to donate if they are having the 1, 2 or 3 electrons. If in any element there are more than 3 electrons, it will never donate. It will always share. Okay. So you can simply remember that if element having the 1, 2 and 3 electrons, it can donate, whereas if electrons are higher than 3, it won't donate, it will simply share. Okay. So this is what the summary of this one. I hope so it is clear to everyone. Okay. And yes, the bonds which is being formed by the sharing of electrons are known as the covalent bond, whereas the bonds which are formed by the donating and the accepting of electrons are known as the ionic bonds. Okay. So carbon forms the covalent bonds, not the ionic bonds. Okay. And yes, let's move on. I hope so nobody is having any doubt. There is one more question to you guys. Please read the question carefully. Tell me the answer. Means it is also the discussion. Read the question or make up an answer in your mind and just tell me that yes sir, we can start discussing it. Then we will check out what should be the appropriate discussion answers for this one. Yes, neutrons are present with the protons in the nucleus. Okay, so let's check out the solution part. The question is saying you must have observed during the formation of an ion, cation and the anion. I have told you about it. Transfer of electrons takes place. Why do you think it is only electrons being transferred and protons staying in comfortably in the nucleus? Okay. Moreover, according to electrostatic force, a proton repels a proton. So due to the repulsive force between the protons, a nucleus should just explode, but that doesn't happen. Why? Okay, so let's check out. First, why are only electrons transferred? Okay, electrons are attracted by the positively charged nucleus because of the electrostatic force. Electrons revolve in some distance away from the nucleus. Even though the electrons are held to the nucleus, the distance present between nucleus and the electrons is always for them to overcome the electrostatic force and force of attraction and get knocked out if energy is provided. Okay. However, the nucleons are held very closely. This happens due to different type of forces acting between them, called the nuclear forces. Okay, so let me summarize it. You can simply say the electrons are present in the outermost shell. Okay, so right now only the force of attraction by the nucleus is working on them, and whenever you supply the energy to the electron, what will happen means outer energy. I'm talking about the outer energy, the energy from the outermost sources. Okay, so electrons will gain that energy and they will simply leave their orbit in which they were revolving initially. Means the force of attraction was over now and they can just get out of their current orbit. Okay, this is why only electron get transferred. Okay, and the point for the nucleus, simply there is a nuclear forces and which are very strong forces which binds them together. Okay, due to which they stays in the nucleus, protons and the neutrons. Okay, now a little bit more information about it. At the level of nucleons, that is a nucleon means neutrons plus protons. That is at a distance about 10 to the minus 15 meters or less, nuclear force takes over. This nuclear force plays a role in binding the nucleons together, about which we will study in the higher classes. However, this doesn't mean that it is impossible to make nucleus explode. We can do if you provide lots of energy. Such a reaction is termed as a nuclear reaction. Okay. And the question is, but won't the electron of the other atom repel the electron? Yes, they will definitely repel. Whenever an electron gains by other atom, surprise, I'll tell you them along in the 5 minutes. Okay. Whenever electrons are gained by the other element, what happen actually? The inner electron which were already present over there repels that electron. Okay. But the nuclear force is much more higher as compared to that repulsive force. Therefore, at last the electron get gained over there. Okay. I hope so it is clear to everyone. Nobody is having any doubt. If you are having any doubt, please ask me. Okay. Atomic number. I have given you brief idea about it already. Okay. That the total number of protons lying in the nucleus of any atom is called the atomic number. Okay. An atomic number is the identity of an atom changing. Atomic number means changing of the atom. It is represented by the Z. Okay. Atomic number is nothing but the number of protons or the electrons in the neutral atom. That is the important point. Okay. So first of all, copy these 4 points. I'll make it simple for you that atomic number is nothing but the number of protons or the electrons in the neutral species. Or you can say atomic number is equals to what? Number of protons is equals to number of electrons. Okay. So this is what the atomic number means. Okay. Please copy this one, and if you are having any doubt, you can ask me. Please copy and then confirm. Copied. Okay, copied, then confirm. First of all, there is no proton, that is proton. Proton is nothing. Yes, protons are equal to number of electrons is equals to atomic number. But remember that is applicable only in the neutral species. In the ionic species, it is not possible. Okay, means in the ionic species, protons would be the same. Means proton are fixed, but electrons will definitely be changed. Okay, for the neutral, it is true. I hope so it is clear to everyone. Copied? Okay. So guys, the point is, you are having the class, means today's class is up to 5 o'clock only. Okay. It means it's over now. Okay. So we are left with a few topic only that will hardly take half an hour. Okay. that we will cover up in the next class whenever we meet next time. Okay, so please be on time. And yes, thank you so much, guys. I'll see you next time. And whatever queries or question do you have, we can solve in that in the next class. Okay, from whatever chapter you have. Okay, so see you next time, guys. Till then, take care. Bye bye. Have a good time. See you next time. Good night.